E aí galera, eu tenho dois encoder rotativo desses aqui e dois motor de para-brisa que eu pretendo transformar em servo motor. Para isso eu vou me basear no vídeo que vem na sequência desse, mas eu não vou usar a BTS 7960. Eu pretendo usar esse driver i2c aqui. Aqui está o segundo encoder incremental. Aqui está o segundo motor de para-brisa. O software que já está funcionando. Agora falta transformar em encoder para ler o PiD nessa plaquinha aqui que também tem vetor de PiD.
I've taken the armature off, and I've taken these screws off of here. We can take a little peeky poo inside. So I thought I was going to find a whole lot more clues in here, but let's see if we can pull this up and figure out what's going on. We've got a couple relays on here. We've got a microcontroller of sorts. These are the wipers that follow those pads on the motor. That's how this guy knows where it is. Our pins here, you can see this large pin is ground. This middle pin seems like it's 12 volts. It's going to these relays. This one is a dang mystery. It just goes into all the circuitry, as well as these ones. So, I think we're safe to assume we got our 12 volts and ground here, and the rest are all signal pins for figuring out the wiper speed and whatnot. So, let's go poke around in the truck a little bit. I actually found a pinout, and I am dumb, guys. I've been messing with this for like an hour or so, trying to figure out what kind of signal drives this thing, and I was poking around looking for an I2C signal, or a PWM signal. But I forget this is a 2003 truck. It's a lot dumber than that. It's just a variable resistor. That's super easy. We can Arduino that, no problem. In order to measure resistance with an Arduino, we're going to use a voltage divider. It'll be configured like this, and we'll use this formula to figure out our resistor. We already know voltage in, we can measure voltage out, and we know the value of resistor 1. So, by doing some fancy mathematics, if you want to call algebra fancy math, we can figure out the value of our resistor. And for now, we'll just print that to the serial monitor. So, I've got an Arduino Uno here. We've got it in the off position, and it's pretty noisy. We're reading a lot of very high resistances. Now we can cycle through these settings. So that's 1. We've got 1,000 ohms. 2. 1,800 ohms. We got 3,000 ohms, 5 to 6,000 ohms, 10,000 ohms, 6, around 400 ohms, and then the top position should be off. So, yep, we're reading some pretty ridiculously high things. Beautiful. We can use that. Now let's figure out how we're going to control that motor. Thank God it's cold out here. In order to control this guy, we've got a couple options. We could just send it pulses the way that the original board did. But I think it'd be much cooler to control it like a servo. And the only difference between this and a servo knows where it is. So, I got me a little rotary encoder here that we're going to whack onto this guy. Now, with a rotary encoder, it just continually adds or subtracts as it goes around. There's no real home position that we can find with this, at least not, I don't know how. So, we're going to have to keep our little home position contacts involved here. And this board is already built in a way that the home position is in the exact right spot in regards to the plug and the motor connections. So, I want to use this board. I want to keep it, but I don't want any of this stuff. Don't mind me. As you can probably see, I've sufficiently mutilated this board, but not too mutilated. I've done a continuity check all across the board to make sure none of these pins are sneaking through, but I don't know if you can see those ruts that I chipped out of the copper traces. I think we're fine. We gotta figure out how to mount this rotary encoder, and as luck would have it, This hole is directly centered on the center of the shaft of the wiper motor. And honestly, I'm just gonna mount this thing to the PCB. Whoa, no. Beauty. Now to get the encoder to index onto the thing. Index? Is that the right word? We're pulling kind of a risky move here. Man, those nylon shavings are just sticking to the grease. There, we'll let that stick to the grease for a little bit. That is the least centered hole I've ever done in my life. Alright, so I've attached my encoder on here. Now, I'm going to solder little wires onto all these pads so we can hijack them and pull them out of the case.
2 hours later.
Alright, it's a mess. You can see I have my nice hot glue strain reliefs. Patent pending. Now, we got to shove this in here. Wish me luck. It's in. Now, before we install this on here, I got to get some new grease in there. Well, hello there, little tractor. Don't mind me. Ooh. Ooh. Disgusting. I hate grease. Now then, one last thing before I install this. I'm going to fill this middle part up with JB Weld. Now the JB Weld isn't actually there to transfer any of the energy, but because I kind of drilled an off-centered hole and had to elongate it, it's going to keep everything in the middle. The grub screw, if you will be transferring the rotation. This is just kind of insurance. Now then, we got 5 minutes to do this. God, I hope that's in the right place. And then to tighten up that screw, I've just drilled a hole in the side here. That should be it. Now, to keep all this nice and waterproof-ish, I'm just gonna slide this PVC cap in place. This is gonna be super glued and hot glued and siliconed. Hopefully everything inside there is okay, but I'm gonna let that set up overnight. Cross your fingies. It is tomorrow. Everything's all dried up on here. I think it's reasonably weather tight, and it works. You see when I turn the arm, I get values from the encoder spit out. So that seems to be working. Now, the electronics. So to control this whole system, we'll use an Arduino Uno. Now we have our motor with the encoder on it, and using the encoder we can figure out where that motor is in its rotation. To control the motor, I'm using a BTS 7960 motor driver, and that will allow us to control the speed and direction of the motor using PWM signals. In order to make the motor go where I want it to, we're going to use a PiD loop. And PiD is just a feedback system in which you can have a set point and it will get to that set point using P, I, and D as different ramifications on how we'll get there. We're just going to use a little bit of P. Otherwise the motor is kind of erratic. Just for testing, we're going to use a potentiometer to choose our set point. If the set point is lower than what the encoder is reading, the motor will move counterclockwise. If it's higher, it will move clockwise. Simple. Alrighty, got it all prototyped up. Let me turn the power supply on. So, when I turn this pot, it moves the wiper motor. Sorry, it's jiggling all around. Pretty cool, huh? Now you might be able to hear that dial-up internet noise. It does a bad job at holding position. I'm sure I could tune it out. I tried for a while and kind of gave up. I think that's a product of feeding this board PWM signals based off of the PID controls. So what I'm thinking is happening is once it gets close to the demand position, it slows down, and the PWM signal that it's sending this board is too small to actually move this motor to complete that. So it's just constantly trying to get to the set point, but not getting there. My solution to this problem is I'm only going to use PWM on this thing when it's actually following the music. That way it will always be moving, so no buzzy holding sound. And then when I'm just doing normal wiper functions, I'm just going to be sending this digital signals, which this board can take those too. So easy fix. Now then, we got it moving where we want it to move. Let's make it listen to music. So to get signals in from the music, we're going to use an MSG EQ7 spectrum analyzer. And this board is pretty cool. in that it already breaks down the music to 7 different bands of frequencies. We're just gonna hijack the one for drums. The Arduino will take this information and create a running average, and every time the signal crosses that running average, it will flip a variable, changing the set point from 180 degrees to 0 degrees. And that, plus our PiD control loop that we put together earlier, will make the motor go back and forth to the music, hopefully. Well, as it turns out, beat detection is quite the little rabbit hole. But here we have our jumble of wires. That is our finished product, if you will. Let's take a little look-see. I've got it all set up to work as regular windshield wipers. So let me show you that. And this is using the resistances that we pulled off of the connector. So this is just one mode. I think it's 3K. I think these are 3 1K resistors. And each mode just has a different delay between full turns and a different speed for the motor. For our windshield wipers, you can see the little relay guy here. When there is a very low resistance across here, it turns the relay on for as long as I hold the button down, and then once I let the button go, the wipers will keep going for another 3 seconds or so. Now, so by shorting this pin to ground, we get party mode. You see it's making that familiar holding line. Much more erratic, but it may follow the music better. It's kind of hard to tell here. It might look a lot cooler on the windshield wipers. So, nothing to do but to take this guy and whack it into the truck. Got my electronics mounted down here. As you can see, I 3D printed a little case for it. And as you can also probably see, I had to cut a hole in the hood. I'm gonna 3D print a cover for that later, but I'm out of white filament for now. But the moment of truth, let's go for a drive, huh? Screw it, what am I stalling for? Let's go party mode.
So lyrical, like a criminal. The feeling so subliminal, like it's fictional.
Look at that!